QuesTek has designed a high-performance stainless steel laser powder bed fusion alloy for use in complex shapes with high corrosion resistance and high strength for the Navy. Its capabilities allow it to be printed and processed without post-processing heat treatment, which give the Navy a much smoother transition to make parts and faster delivery into industry and to the warfighter. QuesTek is a small business and a materials consultancy with over 20 PhD engineers and a total over 30 metallurgists to help industry innovators solve material challenges. QuesTek applies their world-leading integrated computational materials design software and methodology to solve these problems. We can solve many of the problems by applying the computational aspects of materials design and allow for a much faster and much cheaper insertion of materials for solving design challenges. On the right-hand side, you can see that QuesTek developed the M54 Navy landing gear for the T-45 trainer and also qualified for the F-18. We were able to do that in a very small amount of time, less than 7 years, including approval and certification with AMS certifications. QuesTek has engaged in over 600 materials by design, government, and corporate programs, and over 75 of those have been specific to AM alloys. This particular alloy we've patented, and it's the 17.4 Concept 1, where we're able to achieve that high strength and high corrosion resistance without having to do a significant amount of post-processing treatment so that applications can be deployed for the warfighter and the industry at a much faster pace. At the beginning of this program, QuesTek was challenged with the need to create a 17.4 material alloy for 3D printing that was reliable in performance and also reduced or eliminated the post-processing capabilities. QuesTek applied our ICME approach and interrogated ways in which we could look at the processing as well as minor changes in chemistry that would allow us to print in a process parameter set that achieved the ability to self-anneal and self-age the 17.4 it was printed, thus allowing for an alloy that required very little post-heat treatment. QuesTek was able to design not one, but two novel alloys to support the program. Each meet the properties of ROT 17.4 and have the same corrosion resistance. The first one was designed as for direct aging. So once an alloy is printed into a component, only a minor low temperature age is required for the component to meet both mechanical and corrosion resistance of ROT 17.4. The second alloy, QT 17.4 Plus, was designed to be used as printed, eliminating all post-processing thermal treatments. This alloy also meets the ROT properties of 17.4 as well as demonstrates superior corrosion properties. The current status of the program is shown. The laser powder bed fusion specification has been established. We were able to develop a robust set of processing parameters to support printing to meet the properties without the post-thermal treatments. We were able to achieve mechanical and fatigue properties to meet the ROT properties of 17.4. A U.S. patent has been issued for that particular novel alloy. There are some next steps. We need to be able to supply and support establishing licensing agreements with material suppliers for that particular alloy, and that'll allow a much broader inclusion into the additive printing world and have a much larger presence within industry. And then the other next steps were to be established processing and printing parameters for large format DED processes like powder DED, wire DED, and cold spray. QuesTek has been able to demonstrate the printing on a component level demonstration part. We were able to print a CH53E eBay door handles, and the parts were only aged at H900, and then we verified the dimensional accuracy. So not only were we able to meet the strength requirements, but we also verified that the component was able to meet dimensional accuracy in the as printed and aged condition. QuesTek is able to demonstrate via testing and validation the key features and benefits of the 17.4 novel alloys. So both alloys have better than as-built yield strength than commercial 17.4. They both have exceed the properties without post-heat treatment on yield strength and elongation. It also shows excellent ambient toughness, and the fatigue performance shown on the right-hand curve exceeds the properties of wrought material. Corrosion resistance is better than expected, with pitting resistance as predicted by the PREN test, and the 17.4 Plus shows significantly better pitting resistance from the same test against wrought 17.4. So to transition this novel alloy to the fleet, we have to establish additional use cases and components for repair. And there are plenty of opportunities to do that across not only the Navy, but other military applications. And we want to establish the capability for print and go capabilities, even at forward bases. And the most important aspect of this is approach the AM OEM equipment manufacturers to let them understand how that they can offer this on their particular platforms. So not only support the military and the warfighter, but also to support a broad spectrum of corrosion-resistant high-strength components in industry. QuesTek estimates that the market value for this novel alloy is in excess of $60 million. The reasons being is that it's the first considered to be a true print and go alloy that has the high strength and high corrosion resistance available to the marketplace. This improvement will allow that particular alloy to be used across a number of applications, both for the military as well as industry. It is expected that a minor increase in procurement costs will be realized via mature production, but that minor increase will be well offset by the decreased amount of processing steps that has to take place to deploy a component. We believe that transitioning the alloy to large format DED printing applications will also provide a much stronger and exploit further opportunities in the marketplace. This novel alloy with high strength, high corrosion resistance, and print and go capabilities will allow the DoD to be able to print components and deploy them much faster than the standard components that can be deployed by AM. It will allow the DoD to bring components to forward bases, potentially print them at forward bases, and bring new components and replacement components to the warfighter very quickly. This will allow for streamlined uses in the military, as well as streamlined use and industry, in both cases supporting the overall warfighter effort. As both industry and the military desire larger, more structurally efficient components, the next phase of commercialization certainly is to look to create the print and go capabilities for large format DED applications. Doing so will allow a much larger complement of components to be printed to support the warfighter. QuesTek has been very proud to support this program and very happy that we were able to create not one, but two 17-4 alloys that meet the corrosion resistance, the high strength, and the print and go capabilities that support the military. Please feel free to reach out to us via our website or our generic contact information, sales@questek.com. If you choose to email us, that contact will go to more than one. It'll go to several people within QuesTek. Feel free to also call and contact at our main number. And also you'll see our address shown on that slide. We appreciate the opportunity to work and support the government programs. QuesTek is very, very confident that this alloy will get great use in not only the military, but also across industry. And we have appreciated being able to support the program with our efforts. Thank you.